So the first question says we need to find out the UDP length, and here we have 4 options are mentioned. So if you notice here, out of all the 4 options, we are given IP length, means we have to find the UDP length with the help of this IP length information. Actually, if you look at this question, the correct answer is this: IP length minus IP header length. Now, how this answer is correct, let me explain you. So we know that when the message travels from one machine to another machine, it has to pass through all the layers. So it starts from the application layer, and then it goes to transport layer. So this is transport layer where we have a UDP message, and then it goes to the down layer, which is a network layer. Network layer is basically the IP datagram, and then it goes to the down layer. So if you look at this, at the network layer, this is the payload part, this is the header part. So, and this is your UDP packet. So if I want to find out the UDP length, so in terms of IP from this entire packet, if this is given to me, if I subtract this part, header part, I will get the UDP. So here the answer is UDP length can be find out from the entire IP length. If I subtract the IP header length, then I will get this payload, that is the UDP. The next question is on the ICMP. So ICMP message is arrived with the following header information. So ICMP message consists of 8 bytes, means the header consists of 8 bytes. And here we have, if you remember, the ICMP messages are used for error reporting. And all the ICMP message have first 4 bytes common for all the messages. And then other 4 bytes are varying depending on the nature of the error. So here if you see, in the ICMP, the first part is the type that tell what is the reason for this error. And then the next is the code. We have various reasons for a particular type of error. So here we have, if you look to the structure of the IP format, then this is the structure. So here you can see type 5. In this case, this is a type information which is 5 here, then code, then checksum. This is 1 byte, 1 byte, 2 byte, and this is entire 4 byte. So this information is given to us in the hexadecimal format, and we need to calculate what is the address of the target router. So we need to find out of this given values, which part represent the IP address. So how we can find out? So here you can see that this is your type 1 byte, then this is your code 1 byte, and this is your checksum 2 bytes, and then this is your 4 bytes, this field, IP address of the target router. So this is given in the hexadecimal, this is base 16, and we need to write in the term of this decimal format address. So how we can write? We need to convert this. So this is straightforward. This is 2, this is 3, this is 11, and how I can write 11? This 11 in the hexadecimal. So that means I can write 1 into 16 base power 0, 1 into 16 power 1, which is 16 plus 1, which is 17. So I can get the address 17.11.3.2 is the address of the target router. You can check, this is the field which is required. Now question number 3 is again, it's a kind of same question, ICMP message with the same set of values. We need to find out what is the type. So again, as I told you that we have different reasons for the error, and these errors are represented by the type. So here the type is 5, which is representing the redirection. Next question is based on UDP. So here the UDP header information is given to us. UDP header is again 8 bytes, which consist of 4 fields: the source port, the destination port, the total length, and the checksum. And each field comprises of 2 bytes. Okay, so you need to find out the length of data. So to solve all these questions, you must be knowing the structure of this protocol. So in our case, UDP, this is the structure. So it is a header format, This is 2 bytes, 2 bytes, and 2 bytes and 2 bytes. So from here we need to reach to this location, total length. So how we can find? Let's see. So here you can see this is your source port information. This is your destination port information. This is your total length information, and this is your checksum. So our interest is to find out the total length first, because our concern is to find the length of the data. So total length means it consists of both the things. It actually defines the data plus header. So we will see that what is the size of the total length, 001C. So 001C base 16, it actually represent C is 12. So you can write 12 into 16 base power 0 plus 1 into. So this is equal to 16 plus 12, which is 28. That means the total size is 28 bytes for this UDP. And we know that out of 28, 8 is the size of the header. So the data size is 28 minus 8, which is 20. So 20 bytes is the answer. So now question number 5. This is purely based on the concept. There is no numerical required here. Which transport layer protocol is used to implement the Treesat command? So you know that here we are using ICMP, and this is implementing using the protocol which is used as a transport layer. So in the transport layer, basically we have TCP and UDP. So the Treesat is basically a command which finds out that who are the routers, who are the routers which are involved when you are doing communications from a source to destination. So if you want to know who are the routers and you want to know the IP of these routers, then we are using the Treesat command. And to perform this, we need one protocol from the transport layer, and we are using UDP. So this is something that you have to remember, that to implement the Treesat command, UDP is used. So the answer is UDP for this question. Now question number 6. Question number 6 is again based on ICMP. As we know that ICMP objective is mainly two objectives are defined for ICMP. One is the error reporting, and the other is the query messaging, which is basically to for the troubleshooting purpose, to find out the efficiency of the network, find a round trip time. This kind of stuff is done using this ICMP. So timestamp is a query message type. Echo reply request is a query message type. So here we are using this second part of this ICMP. Here we are provided 4 information. So timestamp, a message packet is delivered, and we have this information. We need to find out the round trip time. So again, I repeat, to solve all this question, you must be knowing the structure of ICMP. So in the ICMP timestamp, we are sending the sender time, and we will use that information to find the round trip time. This is the structure of the ICMP. So you can see here, the first 4 bytes are common for all. And then we have original timestamp, received timestamp, and transit timestamp. Original timestamp is the time when the packet is delivered from the source side. Received timestamp is the time when it is received at the destination. Transmit timestamp is the time when the receiver replied back to the sender. That is a transmit timestamp. And return time is the time when the sender received the reply from the destination. Means when he received the acknowledgement from the receiver. That is the return time. So we have some formulas given here. We will use this formula and we find the round trip time. So if you look at this formula, so here we have received timestamp is 48 and minus 37, which gives you 11, and return timestamp is 65 minus 50, which is 15, and round trip time is basically a time, the time taken to deliver a message and get the reply back is called round trip time. So here we need to add these two time, and which is 26. So 26 is the value here. Question number 7 is a ping command. Again, it's a ICMP kind of protocol is used, and here we are using ICMP second objective, that is a query message type, and here you are using echo request and echo reply. So ping command is basically we are implementing using the ICMP, and the objective of this command is to check that the destination or the destination machine or the point where you want to connect is active or not. So if you're getting a reply from your destination, that shows that the receiver is active. Also in the echo request and echo reply format, you need to remember. So in the echo request, there is a data part, and the data part may contain some value. That value cannot be changed, and the receiver will reply with the same value back. So if the sender is sending some value, so before we do the solution, let us look at this format. This is the format for echo request reply. So 8 is for the request, 0 is for reply, and then code, and then checksum. So whenever this command is delivered, we are assigned one identity, and then we send, by default, we are sending 4 messages. So we are assigned sequence number 1, 2, 3, and 4. And there is some optional data. So you may use this place to get some calculation, to get some information. Otherwise, you can fill this all with 0, 0, 0. So in our case, when you are implementing ping command, you can use it to find out the round trip time. So how it works, the sender is sending a request that contains some value. Let's say it contains A in the data part. Then the receiver has to reply back, and it will not change anything. It will keep the same A here. So in our case, a message is delivered, and we are keeping some value here, which is this thing, 72,100,000. This is one value we have kept here, and all the calculation which we are doing here, it is done in terms of milliseconds. So one packet is delivered, and then the sender got a reply at this time, 2:10 a.m., and we are asked to find out the round trip time. So first objective is to convert this time into the millisecond, so that you can kind of compare the two values, or you can do some calculation using these two results. So 2 hours 10 minutes means, hours means 2 into 60, that is 120 minutes, and then 10 minutes is also there, so this becomes 130 minutes. So if I want to convert into seconds, so I am going to do it 130 into 60. So it will be 78. This will be a seconds. So if I going to convert milliseconds, then I multiply by 1000. So this become, this value is milliseconds. Now this is the time when I got my reply. I mean, this is the value which the sender get the packet back, and this is the time which he has kept when he delivered the packet. So in order to find the round trip time, you need to subtract this value, and you will get, this is 60000. This is the actually round trip time, which is milliseconds, but we need to find out the round trip time in minutes. So what is required, you are going to, this is the value we are having, this is milliseconds. Let me repeat again, milliseconds. If I divide it by 60, it becomes, first I will convert, divided by 1000, it becomes seconds, then I divide by 60, it becomes minute. So 4 and then 1, so you'll get this 10 minutes. Okay, so I am moving to the next question. Now in this question, there is no need to do any calculation. This is purely a conceptual based. It says the third fragment of any packet is discarded by a busy router. In this case, ICMP source quench packet will be generated. Scenario is actually correct, means whenever the router is busy, it is going to discard the packet, and it will send the ICMP source quench. This is means the error is correctly identified, means whenever the router is busy, it will discard the packet, and it will tell the sender that I am busy, I am going to discard the packet. And this is basically used for flow control. Flow control means to inform the sender that I am not able to process your packet, kindly slow down your speed, and we call it as a source quench. But in this case, there will be no ICMP packet generated even if the router is discarding this. So the answer is false here. Why? because there is a rule. You can see here, these are the four cases where ICMP is not generated. Normally, whenever some error is occurring during the delivery of the packet, then the routers are going to inform the sender that your packet is discarded and this is the error. But we have four cases when the ICMP packet is not generated, means no information is delivered to the sender. So if you look at the second case, it says no ICMP error message will be generated for a fragment datagram which is not the first fragment. That means ICMP message is only we send back to the sender if the first fragment is going to be discarded. If any other fragment is discarded by the router for any reason, there is no ICMP will be sent to the sender. So here if you see, this is third fragment. Third fragment is going to be discarded, not the first fragment. So in this case, the answer is false. There is no ICMP message will be generated.